In this video, we're going to prove the theorem that says if two angles are supplements of the same angle, or two congruent angles, then those two original angles you started with are actually congruent to one another. So we're going to say that angle 1 and angle 2 are supplements, angle 3 and angle 4 are supplements. But we know that angle 2 and angle 4 are congruent. So essentially we have two angles, 1 and 3, that are supplements to congruent angles, which are 2 and 4. Can we then prove from that information that angle 1 is actually congruent to angle 3? Okay. Given the information, angle 1 and angle 2 are supplementary, angle 3 and angle 4 are supplementary. I didn't put this in yet, but angle 2 is also congruent to angle 4. Okay. Going through my vocabulary, I see supplementary. So I'm going to write that measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. That's your definition of supplementary angles. Okay. They use the English word supplementary, so I can make that statement in my reason being definition of supplementary angles. I can say the same thing about 3 and 4. Measure of angle 3 plus measure of angle 4 is equal to 180 degrees. Okay? And now we've got that pattern of two things equal to the same amount. Okay? Two sums equal to the same amount, so let's set those sums equal to one another. So I'll set measure of angle 1 plus the measure of angle 2 equal to the measure of angle 3 plus the measure of angle 4. And I made a mistake here. That should be angle 4 right there. It's saying, it said angle 3 and angle 4 supplementary, so I should have had angle 3 plus angle 4. And that's just going to be either the transitive property or the substitution property. Okay, and the other videos I explain, if that's statement A, that's a generic statement B, so that's B as well, and this would be generic statement C. The transitive property says if A is equal to B, but B is equal to C, then I can make the argument that A is equal to C, and that's what we've done here. A equals to C. From there, the pattern continues, as it usually does when we see two sums equal to 180. We set those two sums equal to one another, and then we try to remove something from both sides. Looking at this, I don't see a symbol that's on both sides. I don't see measure of angle 1 on both sides. I don't see measure of angle 2 on both sides. I don't see measure of angle 3 on both sides. I don't see measure of angle 4 on both sides. So I can't subtract symbols for the mere fact that they're identical on both sides. But if we look at the given, we knew that angle 2 was congruent to angle 4. So if angle 2 is congruent to angle 4, then measure of angle 2 is equal to measure of angle 4. Okay? And what's nice about knowing that is that that value of angle 2 shows up on the left and the value of angle 4 shows up on the right. Since they're the same thing, we can remove them both from the left and the right. Okay? What allows me to say measure of angle 2 is actually equal to measure of angle 4 follows from that statement right there. Okay? Those two go together. If I say angle 2 is congruent to angle 4, then I'm allowed to say the measurement of angle 2 is equal to the measurement of angle 4. That's your definition of congruency, being able to change from congruency to equality. Now that I've said that, I've told everybody, hey, the value on the left is equal to the value on the right. Now you can remove them. So when I remove those things, I'm going to be left with the measure of angle 1 equal to the measure of angle 3. And actually removing 4 and 2 from the left and right is subtraction. Once you've removed those, you're left with these equality statements. You can now say if the measurements are equal, then the shapes themselves are congruent. Going from equality to congruency, from that step to that step, that is the definition of congruency again. So there we've started with two angles that are supplementary and another two angles that are supplementary. But angle 1 and angle 3 are supplements to the same angle, or the congruent angle. Therefore, angle 1 and angle 3 are actually congruent to themselves, okay, or congruent to one another. Think of it this way. If I know that these two angles are, angle 1 and angle 2 are supplementary, and angle 3 and angle 4 are supplementary, if for any instance that, measure of angle 2 was like 30 degrees, and angle 4 then would have to be 30 degrees too, because we know 2 and 4 have to be congruent. Well, that's going to force angle 1 to be 150 degrees, and angle 3 to be 150 degrees. What do you now know about those two measurements? Well, those two measurements are equal, so those angles have to be congruent. So angle 1 would be congruent to angle 3. Okay? The same thing would hold. Try any value that you would possibly want for angle 2. If I tried 11 degrees, then angle 4 is going to be 11 degrees. And if these are supplementary, then this angle here is going to have to be 169 degrees. So this angle here is going to have to be 169 degrees. Okay? Now there's an infinite number of values that you could try for the measure of angle 2. Alright, so we could sit here all day, forever, trying to show all the possible ways to convince ourselves that, if this angle 2 is congruent to angle 4, then angle 1 has to be congruent to angle 3. But this proof allows you to basically make the argument that it doesn't matter what values we use, it's always going to work. Whether this is 11, 12, 15, 30, 45, 10.258, it doesn't matter. These two angles, 1 and 3, will always end up being congruent. If 1 is supplementary to 2 and 3 supplementary to 4, but 2 and 4 were congruent to one another, angle 1 and angle 3 are going to end up being congruent to one another as well. Okay?